Okay, so what do I mean by that? I mean this. If you read this paragraph, and I'm not sure if this paragraph is going to make a lot of sense to you, but it will in just a little bit. It says the triangles at the right have one pair of congruent angles. You guys see it? This is the same as this. Okay, let's make up a number. Like what?
7.
How much?
7.
That looks like 7 degrees.
Oh, no, you said good numbers.
Okay, let's make it better.
70.
70?
30.
I like 30. Okay, so this is 30, this is 30 is what they're trying to tell you, right? Okay, then it says, and 2 pairs of what? Congruent sides. So what they're now trying to tell you is if this side is 20, so is this side. Okay, and then they're trying to tell you if this side is 12, then what's this side? No, they're saying they're congruent. 12, 12. So with those dimensions that I just gave you, 30 degrees, 20, 20, and 12, 12, how many triangles do you see? There's 2 triangles. So you have to come up with both answers to it. You're going to say, triangle 1 has these dimensions, and triangle 2 has these dimensions. You have to come up with both triangles, okay? But the problem is, there might be 2 triangles, or there might be 1 triangle, or there might be none. No triangles, okay? So would you please make a picture for yourself up there? Slide way up to the top and draw 3 pictures. The 3 pictures are, when would I have 2 triangles? When would I have 1 triangle? And when would I have no triangles exist? Okay? Okay, now first of all, just so you know this only happens when you are given this information. Side, angle. Side, angle is the only time you'll get this kind of version of the answer. Now, side, angle, I'm going to give you the same thing I just gave you. 30 degrees. This is 20. I'm going to make this one 13. Okay? So, with that information, there's your triangle, but there's 2 of them. So, where's the other one? Use the same numbers. Same numbers. See that 30? You can't change 30. 30 is 30. So, up, over, there's your 30. Okay? You can't change those dimensions, 20 and 13. So how's it going to look? If I call this one 20, which is this one, how is the 13 going to look and still create a triangle? A different triangle.
Put the 13 on the bottom.
Well, 13 is the opposite side of 30.
How does it go inward a little bit?
Inward, like this way?
Yeah.
Okay. Okay, so guess what? That triangle, the 13 could go that way, hit the bottom, or it could go this way and hit the bottom. So this is the situation when you have what? 2 triangles. Your job, go find both triangles, tell me the dimensions of the triangle. Okay, what about 1? When are you going to have 1 triangle? Well, let's draw it. It's still going to be 30. Still going to be 20. Okay, now, here's the deal. This time, because there's only 1 triangle that exists, the other side has to come straight down and hit this segment only once. It's not going to hit it twice, once here and once here. You know, like this one, if you think about it, all this did is rotate around in a circle. That's all it did. And when it hit here, that's 1. When it hit here, that was the second one. But see, this one, if I took this segment right here, guys, if I took this segment and I called this my pivot point, and I started rotating this around in a circle, how many times would I hit that bottom segment? Only once, right here. That's why there's 1 triangle. Yeah, it is. When it's a right triangle, it's 1. But question, Do you guys know what that number is?
1,
That's a 1?
90, or
That's a 1.
Okay, guys, the hypotenuse is 20.
It's a 10.
That's opposite of 30. That's the short side of your 30, 60, 90. It's what?
10.
It's 10. Half the hypotenuse is the short side. So when this is 10, you get one triangle. Okay? Tell me when you get no triangles. It's the same triangle. 30 degrees. Here's a 20. Guess what that third side would have to be to say no triangle exists?
Nothing.
Too short.
Too short, but shorter than what?
10.
Shorter than the 10, yeah. See, this is 10. Make it shorter than 10, like what? Make it 3. If this segment was 3 and you rotated this in a circle, would you ever hit this bottom segment? No, you'd never hit it. So this is when there's no triangle. And it basically happens when the segment over there happens to be less than the height of your triangle. Now, I am not asking you to figure all that out on your own. That's not what I was trying to point out. All I'm trying to point out is, do you agree that there could be 2? There could be 1. There could be none. If you can say yes to that, I agree there could be 2, 1, or none. That's all I care about. Let's go find out what happens. Okay? All right. Here we go. Now, example 1 is right here. All right. Please read this right now. When you have SSA, side-side angle, always assume what? Always assume that you have 2 triangles. Always think there are 2. There are 2. Until you prove no, there aren't. There's only 1 or none. Okay? Okay, when you work out the problem, you will find out if there are 2 triangles. Okay, so here we go. First, let's draw it. Here's your first angle to draw. Draw 35. Call it A. Now, side A is 11. Since I'm going to assume there are 2, I'm going to make sure this triangle does exist. Okay? You make sure it does exist for now. You can prove it doesn't later. Okay, what about this one? 15 is B. Well, I'll make B right here. Here's angle B. This would be a C, I guess. Okay. What we're asked to find is what is the measurement of angle B and angle C. For you to use law of sine, you have to know 2 things. An angle, and what else? Opposite side. Now you know 35 degrees, opposite of 35 degrees is 11. You're good to go. This is good to go. Start setting it up. Law of sine, what do we do on Friday? Sine of your angle. Your angle is 35, right? Sine of 35 degrees over 11 should be the same as?
Sine of B over 15.
You gotta go with B because you know the opposite side of B, 15, right? Sine of B over 15. Some of you are not writing anything. Boy, you guys must be pretty smart right now because I don't think this is easy. 11 times sine of B equals what? $15 times sine of 35. You're solving for what? Not B.
Sine of B.
Sine of B. Let's get sine of B all by itself. How? Divide by 11. Divide by 11. There you go. So, this is what I see. How do you get B? Inverse sine will knock out sine. Yeah. Just do the inverse of sine. That'd be inverse sine. Here it comes. B equals inverse sine of parentheses, parentheses, Drop it in. You gotta have a calculator. 4 of you don't even have calculators in front of you. You're expecting everybody to do your work. Mhm. Guys, when you type this in, inverse sine, you wrap this 35 up in parentheses. You have to, because some of you aren't doing that, and that's why you're getting these wrong. Okay, let's go to the nearest 10. So what'd you guys get? Angle B is what?
51.
51 point what?
3.
3, no.
5.
5, yes. Okay. If you type that in, inverse sine of that mess, it should come out 51.5.
Oh,
I don't know what you're doing to get the 0.3.
I rounded up.
Or are you typing it in and then rounding it?
Yeah.
Yeah, don't do that. Because guys, if you type that in and then you start rounding, you're just giving me a little piece of the answer. Then you're doing inverse sine of it. No. Take inverse sine of the whole thing. Okay, next up. Oh, let's go back and fill that in. Where's the 51.5? It's right here, isn't it? Okay, I got B. Now I'll go get C. Well, if this is 35 and this is 51.5, how do you get C? What is it?
93.5.
Okay, 180 minus, was it 35?
Yeah.
Minus 51.5, right? You said what? 93.5 is the answer. Good. Is there one triangle? Yeah, there's one triangle, guys. The first triangle does exist. You should write this now. You should tell me the first triangle is right here. I've got the answers right there for the first triangle. Okay, what about the second triangle? This is where you guys are going to learn right now. So please watch. Okay, is there a second triangle? Okay, watch this. I'll just look at her eyes. Okay, here we go. Sine of, listen, inverse sine of that ratio, right here, gave you that answer, correct? Now guys, this ratio right here is positive, because you got a positive 51. Here's the deal, your calculator can't give you both answers. Where else is sine going to be positive? What two quadrants? First and second. Sine is positive here, sine is positive there. So if I draw the triangle, and the answer is what? 51.5. Okay, that's the first answer, 51.5. Guess what? That triangle, flip it over. Right here. This is also what? 51.5. So what's the other answer? Right here.
128.5.
Okay, so angle B could have been what?
128.5.
128.5. This would be the second triangle, just so you know. Okay, so there it is. That's now a 128.5. So I could scribble this out if you want me to. 128.5. And I already have a 35 for A. So what's C going to be? Angle C would be, well, what's left for C? Every triangle has 180 degrees in it, minus the 35. Minus the new B. The new B is 128.5. Which leads me to believe angle C would be what?
16.5.
Are there two triangles to this problem? Now, this is the second triangle. Good? Now, do you understand why there's two? Because when you hit inverse sine, listen, when you hit inverse sine right here, inverse sine of this gave you 51. But inverse sine of a positive ratio gives you two answers. Your calculator cannot give you the second quadrant. So your job is to go get the second quadrant, check it out. Does 128 plus the given 35, is there enough for a third angle? We'll just take 180 minus the given, minus this new one. Yeah, there is. There's enough room.
So if there isn't enough room, that's
Then-
why there's only one.
Then you say there's only one triangle.
What happens if there's not a triangle?
Can we talk about that in about 10 minutes? Okay, that's a good question. I just don't want to get too far ahead of everybody.
Wait, so if you do the graph, it already goes over 180.
Yep.
Is that, you can already say that it isn't?
Okay, so you know what? You know what it would look like? It would be a 35 like this, right? Okay, and then it would be something like this. Okay, I'm not drawing this very well, but it would be a 128 and a 16. So that's how the second one would look.
No, but I mean, for on the graph, if there was a different number and it was higher than like 51 and it goes over the 90,
Oh.
then you add it again and it goes like over. Like,
Well, here's the deal.
Doesn't that mean it's not a
Yeah.
triangle?
Yeah, but here's the deal. If you take 180 minus the given, minus what you just found, and you start getting negative answers, this one doesn't exist.
Okay.
Yes?
Yeah.
Okay. You'll see. It's going to happen in the next example. Promise. Okay? Turn the page. Let's just do it again. We'll do it again to see what happens. Hey, you and somebody else. I need to get that quiz taken. There's 2 people. Hey, can we talk to you after class? It's my last day. Can't believe you missed that. First, you got to be able to draw it. If you can't draw it, it's hard to do. Find angle A, find angle C. Always assume there's 2 triangles. Hey, did they give you side, side, side? Or sorry, I said that wrong. Did they give you side, side angle?
Yeah.
Yeah, look. Side, side, angle. They gave you SSA. This is the situation where you go, oh, there could be 2, there could be 1, there could be none. So what do you know? B is 41 and side B is 26. I'm hoping you're ahead of me and not trailing me. Sine of 41 over 26 equals what? Are you picking sine of C or sine of A? I hope you're picking A, guys. Look, you know the opposite side is 12. You have to pick A. Sine of A over what? Over 12. Cross multiply. 12 times sine of 41 degrees equals 26 times sine of A. Sine of A equals sine of 41. And then what do I do to get rid of the 26? Divide by 26. How do you get A all by itself? Inverse. Inverse sine knocks out sine. A equals. You have to do inverse sine, right? Of what? This stuff. Type it in. Eric, did you get an answer? No. Will, did you get an answer?
No.
Aaron?
17.6.
17.6. You guys agree with him?
Yeah.
17.6. Okay. A is 17.6 degrees. Okay, that's what Aaron got, and I heard 3 or 4 people say yes. Are you not getting that? Some of you? Again, you can't get it right unless you do this. Wrap that, wrap that. 12 times sine of 41 degrees divided by 26. Of course, you got to do this first, don't you? Inverse sine. All right, let me go back up. It's 17.6, so I'll put it here. 17.6. That's a 41. Is there enough room for the angle C? Oh, I hope so. This plus this doesn't even come close to 180. There's room. What would C be?
121.4.
One what?
21.4.
121.4. Okay. So here's what I'm going to do. I'm going to go angle C equals, well, 180. Take away the given. What was the given? 41. Take away what you found A to be, 17.6. And I heard Taylor said 121.4. Okay. Hey, the first triangle, it does exist. It's there, guys. First triangle. Right here. I've got C, I've got A, I've got everything. Second triangle. This is the hard part. And I shouldn't say it's hard, because it's really not that hard for you guys. Let's go over here. Right about there. Slide over. You know how when you guys did inverse sine of this ratio, and you came up with 17.6? That means the calculator knows the answer's right here. It's a really skinny triangle, 17.6. Where is sine positive? First and? Second. The other answer's over here. Okay, it's the same triangle, 17.6. What's that?
162.4.
162. So the second triangle, A could have been, angle A, could have been 162.4. Right? Okay, well if that could have been the answer, then I'm going to go back up to my triangle and say, no, not 17, but what? 162.4 is the other one. Plus I already have this 41. Is there enough room for C?
No.
I don't think so either, but let's just show the work. What would angle C be? It'd be 180 minus the given 141 minus this new A, and this new A is awfully big, by the way. Is there a chance?
Negative.
This is going to be a negative angle. It's not going to work. No, what? Second triangle. So you're supposed to assume there are 2, but there's a chance there's only 1. And then there's also a chance there are none. Now Taylor asked me, or somebody asked me, when is it going to be none?
When the original.
Never mind. Okay.
When one side's too small, or smaller than.
It doesn't equal 180.
Do you guys remember why you're able to get these answers? Because you're taking inverse sine of something to get 17.6, right? Okay, do me a quick favor. Let me show you why it doesn't exist, if it doesn't. Would you do this for me right now? Would you go inverse sine of 2/5? What's the answer?
23.6.
Degrees? Okay. What's the answer to this one? 4/5.
53.1.
53.1. Okay. What's the answer to this one? Inverse sine of 5/5. Did you say 90?
Yes.
Okay. Okay, now guys, watch this. Inverse sine of 6. fifths.
Error.
Did you already do it?
Yeah.
Okay. It is error, which means no what?
Trying.
No angle will exist here. Why not?
Leg is bigger than the hypotenuse.
What? Yeah. What does this mean?
The leg is bigger than the hypotenuse.
Yeah, it's supposed to be opposite. Sine is opposite over what?
Hypotenuse.
Opposite over hypotenuse. Okay. Well, what you're saying is one of your legs is 6. The hypotenuse is 5. Isn't the hypotenuse supposed to be the longest side of a triangle?
Yep.
Yeah. This is why there's no angle. And if you get this on a test, you just say what? There's no triangles. Book. It's book all week. Okay. All right. That's why. I don't even have one on here. You know why? Because I think in your assignment today, there's no. You always get one triangle or 2. You don't ever get none. Although none could happen. Okay, you guys, would you do me a favor? Would you do number 1? In your book, it's page 927. It's called the ambiguous case. It could be 1 triangle, it could be 2 triangles, it could be none. Although I just told you, it won't be none.
None.
There are none nones. Timothy.
Why you teach math and not English?
None. That's right. 927, bring your book all week. All week. You get a 1-minute head start. Ready, set, go.
It is
I think it's page 927.
LA
Do number 1.
62. Write it down. So A is 62. And then side A is 30. And then side B is 52.
Give you a hint.
If you want.
Out of these 6 problems, 4 of them, out of these 6, 4 of them have 2 triangles. Mm-hmm. 4 out of the 6 have 2 triangles exist.
Where'd you say you were going?
What?
Where'd you say you were going?
I don't remember saying it.
Yeah, you did. I asked you.
It was
Yeah,
either
you
you
said
said
it.
Alaska, but then you didn't.
South, east,
Dominican Republic.
Dominican Republic.
Why?
I listen to my wife, let's just say that.
You listen. You didn't sound it.
If I had my way, I would have probably went to Florida and watched the Twins play for a week. Don't tell my wife that though.
What's your wife's name?
Mrs. Painter.
I'm gonna call her Ellie.
Ellie, you're kind of close.
Really?
Mm-hmm.
Curious.
Elizabeth. Emily.
Elijah.
Ella.
Elijah.
Joellen.
So close.
You would have never got Joellen though.
I wouldn't.
Now get busy, Hannah.
I am.
Okay, I've got mine drawn. I'm assuming there's at least one. I'm hoping, well, there's probably gonna be 2. That's what I have to assume. Here we go. Law of Sine, I'm ready to go. I know my angle, I know the opposite side. Oh, since this is side B, that's angle B. This would be angle C, side C. So what am I gonna do over here? What's this gonna be?
Sine of B.
Yeah, it's gotta be B because I know the opposite side. Sine of what?
B over 32.
B over 32. Got it. After cross multiplying, I divide by 30. I divide by 30, right? And I get this equals sine of B. Okay, that's sine of B, but we don't want sine of B, we just want angle B. What now?
Inverse sine.
Inverse sine to knock out sine. Do the inverse operation, it's just inverse sine. And then you gotta go inverse sine of that. Whatever that is. And your calculator knows what it is, just say inverse sine of whatever that is. 70 what?
0.35.
Or
is it to the nearest?
Nearest tenth?
It
Does it say anything?
It doesn't say.
Let's just do 10. Okay, so that's the answer, right, guys, for B? Okay, the question is, well, is there one triangle, two? Well, we know we got to check for one. Let's put 70 back in. And of course, we're going to say, if this is 70 and this is 62, is there enough room for the third one? Well, I would think so, because the two angles don't add up to 180. So, what's C going to be? 180 minus 70.4. What was the given? 62. What is C? 47.6. Hey, look. What'd you say?
He said, hey, it's nice to respond with where the monkey is.
Do you know what he's saying?
I have an idea.
Yes.
What?
How do you know that?
Because I watched the show.
What show?
Hey, we're the monkeys. There was a show in the 60s. I don't know. That's me. I got that in my mind. Hey, we're the monkeys. And he says it. How do you know that? There's no way that show is on anymore.
He literally has a whole collection of those things.
Harry, you crack me up.
I'm on my phone too.
First triangle does exist. All right, ready? Come on over. Let's do this one. Okay, guys, when you punch that in, inverse sine of that ratio, and you got 70.4, again, your calculator is telling you 70.4 is the answer in quadrant 1, but in quadrant 2, that same triangle gives that same ratio. So what is it? Here. What's that going to be? Say again?
109.6.
109.6. Okay, so this is the new B. The new angle B is 109.6. Right? Okay, so this would be the second triangle, and we're assuming that there is an angle C. Let's see. Well, the triangle has 180 degrees in it, minus the given 62, minus what? The new angle B, 109.6.
8.4.
Does it come out 8.4?
8.4.
Agreed.
You actually got an answer?
Yep.
Yeah.
Okay. I thought we got two. I gotta look at that. I thought the second one was 1. That's what I'm
Did we do it wrong?
saying. No. So we got 17 points. What we get for the first one?
70.4
Oh.
and 47.6.
Are my numbers different? Okay. Let me go. You say that answer again. What is it?
8.4.
8.4. So you got 2 again, didn't you?
Yep.
So the second triangle
Let's see what that
does exist. So there are the new dimensions for the second triangle. My numbers in my key here, 12 and 26, must be different. Oh, yeah, my numbers are different than your numbers, so that's why. Okay.
You can have it.
That's okay.
I don't like this.
You got it. It's 2 triangles. 4 of the 6 have 2 triangles, and 2 out of the 6 have just 1.